Hello friends, this video on Waves Part 3 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos from Part 1 to Part 2 before going ahead with Part 3. So, in order to study more about mechanical waves, let me tell you about the classification of waves. There are various categories into which waves are classified. You classify waves into two types on the basis of something. Again, on the basis of something else, you classify waves into two types. So, something like that. So, there are many different ways by which waves are classified. So, let us look at this first classification of waves. This classification is on the basis of the direction of the wave propagation, that is the direction in which the wave is propagating, and the direction of the disturbance. As I told you, the wave, what causes the wave? A wave is caused by a disturbance, right? A disturbance is initiated and then that disturbance keeps propagating with time. So, the direction of the wave, and depending on the direction of disturbance and the direction of wave propagation, we classify waves into two types. The first is transverse waves and the second is longitudinal waves. Now let us see what is a transverse wave. Transverse waves are the ones in which direction of disturbance or displacement in the medium is perpendicular to the propagation of wave. That means the direction in which the wave propagates is perpendicular to the direction of disturbance. Now, if you think of it, it is very easy to remember, right? Direction of disturbance perpendicular to direction of wave propagation. But think of it practically. Try to think of it that a wave is traveling. What do you mean by the direction of disturbance? And what do you mean by the direction of wave propagation? So let us look at this example to make your understanding more clear. Let us suppose the small little boy is holding this thread at one end and the other end of the thread is fixed to the wall. Now what happens? If you give a jerk to this thread upward, a small jerk to the thread upward, what happens? The entire thread kind of moves in a wavy manner. However, you did not give a jerk at this point or this point, right? You just gave a jerk at one end. But this jerk propagated along the entire length of the string. So, this propagation, that is the small disturbance which came from the source at one end, that disturbance getting propagated. So, that is known as the direction of propagation. So, in this case, what is the direction of propagation? Direction of propagation is this, because your wave is propagating in this direction. And what is the direction of disturbance? It is this, because the disturbance was nothing but the initiator which initiated this small wavy movement along the thread. So the disturbance was initiated in a perpendicular direction. So if you see, the disturbance was vertically upwards and the wave propagation is horizontally. So that means they are perpendicular to each other. So this kind of a wave is known as a transverse wave. Now this was just an example to make you understand what is a transverse wave. So as I told you before also, how does this wave moves along the medium? What is it that made this wave to travel along this? We gave a jerk at this end. So it could have stopped here itself. Why did it travel at all? That was because when we pull the string upward, formation and propagation of pulse is possible because this entire string is under tension, right? You all know what is tension, because these are all small terms which I introduced in the very beginning chapters, and now you are all aware of it. So since the string has a tension, because of this tension, the small disturbance which you give at one end gets transferred to its neighboring molecules or the neighboring particles. So when we pull one end of the string, it pulls upward the adjacent section. That means, let us suppose you have pulled it here. You pulled it upward here. So this pull will cause its adjacent. Let me consider this. Let us suppose this is the thread which is straight now. You pulled this part. Let us suppose. Now this pull, this thing will get transferred to its neighboring part. Again it will get transferred to its neighboring part. Again it will get transferred to its neighboring part, and this way. So this small pulse will get propagated along the length of the string, and this propagation takes place because of the tension in the string. Now as the adjacent section moves upwards, it pulls the next adjacent section upwards. So when this section moves upwards, it causes its next section, that is this section, to move upward. Again this causes the next section to move upward, and so on. So this is how the disturbance gets propagated along the string. So that is how a transverse wave propagates. Now let us look at another example. This is how a transverse wave generally looks like. The transverse wave looks like an up and down, and that keeps continuing. Now if you observe the motion of a particle, now what do you think are all these particles? I mean, these particles are nothing but the particles of the medium. So as I told you before, the particles are not moving from initial to final position. Particles are just moving about their mean position, but the energy is getting transferred from one particle to another. If you observe this, let us suppose this blue particle, this blue point represents a particle of the medium. Now as the wave moves, I have just taken a small part of the wave. So as this wave keeps moving, what happens to the particle? How does the particle moves? The particle just moves up and down, up and down, up and down. However, your wave is moving in a different way. I mean, if you draw this complete wave, the wave propagation takes place along this direction, but the movement of the particle takes place along this direction, right? The particle goes up and down vertically. So the movement of the disturbance, or the movement of the particles of the medium, is perpendicular to the propagation of the wave. Now let me also clarify what determines or what defines the direction of propagation of the wave. Direction of propagation is defined by, if you see these waves, all these waves as a whole, if you see it in this way, what do you see? The wave is propagating along this direction, right? So that is the direction of wave propagation. Clear? Now to clarify this even further, because I don't want any doubt to be there in your mind regarding these two directions, direction of the disturbance and direction of the wave propagation. Let me explain it once again. Let us suppose this is a wave, right? Now, how is this wave getting propagated? After some time, this wave will go to this position. Again, after some time, the wave will go to this position, and so on. This is how the wave is moving. So now if you compare the first position and the second position, what do you see? You see the particles will move up and down. How? Let us see here. I'll draw it once again. Let us suppose this is my initial wave. After some time, this wave becomes like this. So what happens? The particle which was earlier at this point is now moved to this point. Similarly, the particle which was earlier at this point now moved to this point. Similarly, the particle which was earlier at this point now moved to this point. So what do you see? The particle is just moving up and down, and so on. This is the best representation to this. Have a look at this diagram. This is the best way you can visualize how does a particle moves up and down. However, the wave is propagating horizontally. So I hope you are able to understand what is a transverse wave. Transverse wave is the one where the wave propagates perpendicular to the direction of disturbance. Direction of disturbance is nothing but the direction of motion of the particles in the medium. Also remember that the particles of the medium doesn't move from initial to final position. They just move about their own mean position. They just keep moving up and down about their own position. and the energy gets transferred from one particle to another and so on. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.